if we want to graph this function then, okay, are we given a domain here in this particular problem? Are we given a domain?
No.
No. So, Alex, since we're not given a domain, what does that mean? What's that?
You would make one up.
Yes, you fill in the blank. Thank you. Exactly right. So, Alex, why don't you pick some x values here?
Let's do 0, 1, 2.
All right, and let's just do that many. That's all we'll probably need. We don't have to go overboard here, okay? What should I put at the top of this column over here?
Y.
Yeah, a y. Okay, very good. And so now let's just plug these in, okay? So I'll kind of plug it in here. So let's see here. So y equals 3 times 0 plus 1. So let's see here. 3 times 0, 0 plus 1 is 1. So I get 1 there. Okay. I'll plug in the 1 now. So y equals 3 times 1 plus 1. So 4. Okay. And then y equals, all right now. Oh, plus 1. So 3 times 2 is 6, plus 1 is 7. Okay. Perfect. All right, so now we've got some coordinates, right? Now we've got some coordinates, and we can do something with this, right? So, Sean, now that I have some coordinates here in my table, what do you think I should do to graph this function?
You plug the x values into the, where there's x, like 3x.
Oh, I did. I plugged these x values in. I got their matching y values here. Now that I've got the points, how can I go about graphing? What should I do now to graph this line? What should I do with these points?
Plot them.
Yeah, plot them. Okay. So to graph 0, 1, how do I go from the origin? Which direction should I go? Shh. You don't have to correct it for me. It'll be the same for you as it is for me because it reflects and stuff. So just from here, if I have the coordinates 0, 1 from the origin, which way do I go?
Right.
Right, how many?
0.
And then up or down, how much?
Up 1.
Up 1. Good. So point right here. Okay, from the origin there. Thank you, Sean. You want to do the next one here for me too real quick, Sean? How about for 1, 4? From the origin, where do I go?
You go sideways, right 1.
Right 1. Good. 1, 2, 3, 4. I like that you corrected yourself from sideways to right because sideways is not as descriptive as right is. Right is one direction. You're going to the right. Sideways could be to the left or to the right. So I like that you corrected yourself there. That's good use of vocabulary. All right, let's go to Catherine. Catherine, for 2, 7, from the origin, how do I plot this point? So go right 2, and then?
Up 7.
Yes, 1, 2, 3, 4, 5, 6. Woo, it barely fits, but it does fit. Okay? Now, that's a point I want to kind of bring up here, right? If we're graphing lines, right, and maybe we're looking at our line and like, ooh, I'm not going to be able to fit that on my graph, right? Maybe it's not going to fit. You have some options. Sometimes it's okay to go a little bit off the graph. But if your point is like way off the graph, what should you probably do? Pick another point. Don't use that point, okay? If it's like way off the graph, pick another point, please, okay? Don't try and make it work, okay? Because we want our lines to be straight. Okay, so Matt, those are my 3 points that we found here in the table. So is this the graph of my line? Is that it?
Yes.
Matt T, sorry.
Oh, yeah. I'm pretty positive.
And so is this it?
Oh, no, you don't put a line. You don't connect them.
Right, okay, because our domain here is not listed, so we're going to assume it's all numbers, which means this function is discrete or continuous? Continuous, so you should connect the dots and extend them, okay? So I'm going to connect the dots here. Okay, now if you want to use a ruler, you can. Oh boy.
Can you put arrows?
Yep, and then you can just put arrows there after you've extended it there. Okay, and then arrows, of course, after this point too. Okay, perfect. Okay, great. All right, questions on any of that? Pretty easy, yeah? Now, how many points did we need to pick 3 points here? Did Alex have to give us 3 points? No. What's the minimum number of points we need to draw a line? 1, 2. It's definitely 2. All right, well let's try the next one here and let's see. I hear 1 and 2, so let's see what the next one's going to be like. All right. Yeah, you may. Go quick though. I'm going to change it up here. We'll say f of x equals 4 minus 2x. Okay, f of x equals 4 minus 2x. Okay? So let's see here. Go to. All right, so Carson, we want to graph this line again for number 2. Can I just zoom in here? I hope I don't. Everybody okay with that? Carson, I'm going to graph this line here. Okay. So to graph a line, what do we need? We need some points, right? Just like when we find slope, we need some points. We need some points here too. All right, so let's make a table. Carson, are we given a domain for this line? No. So that means we get to choose what numbers we pick and put in there. All right, Carson, why don't you pick some x values for us here, Carson, please?
Sorry.
3. Okay. Let's just do 3 because we're trying to decide here. Maybe do I only need 1 point? Do I maybe need 2 points? Let's decide that. So, okay, Carson, I got the x value of 3. How can I get its matching y value or function value here? What should I do with that 3? To get this matching value here. Well, we're going to use our function. What should I do with the 3? It's an x value. Plug it in, yeah. So we're going to do f of 3, which is equal to 4 minus 2 times 3 in parentheses there, like that. Remember, when you substitute in, put parentheses around it. Okay. So let's see here. 2 times 3 is 6. Follow your order of operations too, right? 2 times 3 is 6. 4 minus 6 is negative 2. Okay, so let's go ahead and plot this point. 3, negative 2, right there. Okay? Is 1 point enough to graph the equation of a line?
Maybe.
Where do we go next? Where's the next dot to connect?
Anywhere.
Right. Do you see the problem then? We don't quite have enough information to graph this line because we shouldn't be able to go anywhere. We should have an idea about where we're going to go. So let's see that. So we at least need 2 points. Let's see if 2 points are going to be enough. So Carson, can you pick one more x value for us, please? 4. Okay. So plug in the 4. F of 4 equals 4 minus 2 times 4. 2 times 4 is 8. 4 minus 8, sorry, is negative 4. So we get the point 4, negative 4. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now we have 2 points on our graph. Is that enough information
Yes.
to be able to graph a line? Yes. Yes, it is. Okay. What if we did 3 points and like one of those points didn't fit on the graph? What does that mean?
It's don't work.
So if I had picked, let's say I picked one more x value here from Carson. Okay, we plugged it in, we plotted it, but it didn't look like it would fit on the same line. What does that mean about our information here?
It's not correct.
We made a mistake. Yeah. So if you graph more than 2 points or something like that, and you were like, wait a minute, one of these points is off, and you know it's supposed to be a line, they should all be on the same line there. So yeah, now you can connect the dots though. Okay, so I'm going to connect these dots. Let's see here. Ooh, I want to make sure I draw it kind of neat. Okay, remember to put an arrow at both ends because we keep going here, right? Like that. Okay. Now, besides the 2 points we already came up with, can someone give me another point that's on this line? Let's go to someone we haven't heard from yet. So Mark, can you give me another point that's on this line? I'll try and zoom in a little bit more if you need to there. Okay. Can you give me the coordinates of another point that looks like it's on this line?
0 and 4.
0, 4. Perfect. Yeah, if you look here, 0, 1, 2, 3, 4. Yeah, it looks like it has a y-intercept of 4. Very good. Okay. And there's other points we could have given, right? So we really have a point like here, it looks like. It looks like right here. It looks like right there. Well, it should be like right here, too. I didn't quite graph that well. And like right here. Okay, it looks like we have a bunch of points there that we could easily identify. Okay. How many points are there really along this line? If you were to count them up, there would be an infinite number of points, right? Because you can put a point anywhere on this line kind of thing. Okay, cool. Keep going here then. Let's try another one. All right. Number 3. Y equals 1/2 x. Okay. Whoops, I'm off the screen. There we go. Y equals 1/2 x. That's going to be our function, our linear equation, our function here. Okay. So again, I think we all understand here, Matt, but you go ahead and tell us, Matt. So we want to graph this, Matt Snyder. Okay, Matt S. In order to graph the equation of a line, we need to graph some what? Before we can graph the line, we want to graph some what? What did we plot before? points. Some points. We're gonna. Yeah, I know. Maybe I wasn't doing a good job helping you fill in the blank there, but yeah, it's points. Exactly right. Okay. So let's come up with some points. Okay. We'll make a little chart here. X, Y. All right, Matt. S. No question. Yeah, go ahead. Matt S. Pick some X values for us here. 3. All right, let's pick some more X values. 7. Okay.
5.
Let's pick some even. Pick some even ones, please. 2. Okay, we'll start with that. Let's plug in 3. Okay, y equals 1/2 times 3. That'll be 3/2 or 1.5 if you like. Okay, plug in 7. Okay, 7/2 or 3.5 here. If you guys are okay, I'm just gonna like do the math for us in my head, so just to speed things up a little bit. Plug in 2. 2, and I'll put it like a dot, dot, dot there, you get the idea. 2 times 1/2, what is half of 2?
1.
1. Okay, now, since we kind of ran into some yucky stuff here, we got some decimals, right? Decimals and fractions, okay? Graphing decimals and fractions, we can do it. We probably prefer not to, though, right? Okay, so is there a strategy, and Matt, maybe you can answer this. Matt, is there a strategy we could use when you picked your X values, Matt, is there a strategy you could use to maybe make sure we wouldn't get fractions here? Look at your table. You got some fractions when you did like 3 and 7, but we didn't get a fraction when we did 2. Yeah, okay. Why even in this case? What about the equation here gives away that we should pick even numbers? Carson?
When you divide it by, you divide it
Uh-huh.
to, it's always going to pull like by half or something like that.
Yeah.
So it's going to be even.
Yeah, exactly right. So even numbers are divisible by 2. So really the bigger picture here is not just that we always pick even numbers if we have fractions. The bigger picture is you always want to pick a number that's easily divisible by whatever your denominator is there. So in this case, since we're dividing by 2, you want to pick even numbers. It's not wrong to pick 3 or 7. It's just, you don't have to deal with fractions, right? So Matt, question?
Isn't it
Comment?
if you only have a fraction and like an x, can't you just divide them wrong and go?
We'll get to
divide
that.
them
We'll
wrong?
get to that. We'll get to that. Yes, yes. You are onto something there. We'll get to it. Okay? So let's plot these points, though. So 2, 1. Okay, 7, 3.5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3.5. So like right there. And then 7. I did that. Okay, 3 and 1.5. 1, 2, 3, 1.5. Okay, so you can see there are my points. Okay. So it should go something like this, and then something like this. Okay, so there's my line. All right, yeah. So let's do one more together here, and then I wanna show you guys a shortcut. Believe it or not, yes, we are kind of doing it the longer, harder way, but that's okay. Okay. If I were to take any function. If I were to take any function, not just linear, if I were to throw some random function at you and I'm like, graph this, tables are the way to go. Because all you got to do is just pick some x values, find their matching y values, plot those points, and connect the dots. And you get an idea about what the function looks like, right? Okay, now, we know this function, though. We're so familiar with it. It's a line. We know lines. We know what they look like. So we don't need to worry about that. We can start using some shortcuts to kind of help us out. Okay? So anyway, thank you, Matt S. there. Let's go now on to, let's see here. Who haven't we heard from yet? Oh, come on. Give me a good one here. We already talked to Reagan. I don't want to bother her again just yet. Let's go to, all right, well, someone who's here. Come on. All right, forget it. We'll just go on here. All right, so number 4, we'll do one more here together. So y equals negative 2/3 x plus 4. Okay, more fractions. All right, so I'm going to show you this one, then I'll show you the shortcut. Actually, I'm going to have you guys try 2 after this one, and then I'll show you the shortcut. Okay. So, Hannah. Let's use some strategy here, Hannah. What will be some good, before we actually pick some x values, just tell me what would be some good x values to pick. We got a fraction in here. So we want to pick x values that are easily divisible by what number? 3. Okay, our denominator here is 3. Okay, so we want to pick numbers that are easily divisible by 3. So Hannah, can you give me a number that's divisible by 3? 6. Okay, Tyler L., can you give me another number that's divisible by 3, please? Is 1 evenly divisible by 3? No. What can we divide? What's another number besides 6 that we can divide by 3? 9. Okay, 9 works. Okay. Now I'm really surprised many of you guys aren't picking 0 for x. 0 is probably one of the nicest numbers to always pick because you can multiply 0 by anything and you get 0, right? So don't make it harder for yourself, but we'll do 6 and we'll do the 9. Those are good numbers too because they are divisible by 3. Is 0 divisible by 3? Yeah, what's 0 divided by 3? Yeah. Okay, please use 0 if you want to. All right, 3 would have worked too. Yeah. Okay, so now here I'm going to plug it in here. So y equals negative 2/3 times 6 plus 4. Okay, and your calculator, you can type this in, but it's going to be, well, this actually ends up being 0. Okay, this ends up being 0. Okay, negative 2/3 times 6 is equal to negative 4 plus 4 gives you 0. Okay, 9 times negative 2/3. Okay, 9 times negative 2/3. Well, 9 divided by 3 is 3 times negative 2 is negative 6 plus 4 would be negative 2. Okay? Do I need any more points? No. 1, 2, 3, 4, 5, 6. Uh-oh. We're going to have a problem with this 9. Let's just do 3 real quick. All right, so 3, 2 is what we end up with. Okay, 3, 2. Okay? 3 times negative 2/3 is negative 2 plus 4 will be 2. So 3, 2. 1, 2, 3, 1, 2. Okay, and so let's see here. All right, and I just put some more points in there. Ooh. Okay, and there's our line. Again, arrows at the end because to show that it keeps going. Continuous.
Can I say the trick for this one?
All right, we're going to do it in a second. Okay, hold off, Matt. All right, if you know it, you can use it, but I don't want to just share it just yet. All right, so now here are 2 for you to try. Okay, I would like you to try. So you guys graph these both. Graph y equals x minus 2 and graph y equals negative 1/2 x minus 1. Okay, so graph those 2. Sky? Yes. Okay, so go ahead and graph those 2. I'll maybe leave up the first ones that we got so you can kind of remember what you're supposed to do here. Okay, so table, plot the points, connect the dots. So we're just doing number 5 and 6 here, okay, on the bottom there. So you want to give those a try, please. Come around and see these lines. We'll see how we're doing. Zoned out there, Mark? So make a table, X, Y chart, right? Pick some X values, plug them in, find their matching Y value, okay? Good so far? Good job. Good so far? Shepherd, good job. Good so far? Wait, now that I see how it's done before. Okay, looks good so far. Good job. So far, plot those points. You know how to plot points. coordinate. Star. And then 4 is the y coordinate. There. Look at that. It makes a line. Good job. You made a straight line there. Okay. Think you did coordinate. Oh, I see. Okay, this one's right. This one's not. The y-intercept's -1, so you should start at -1 and then go down.
Because I'll help with that one hand.
Yes. Yes. Can you wait until Sky comes back and then go? All right, just so that I don't want people out of time. I don't want to miss
What's
people.
up?
Pick some x values there, one. Pick an x value. Todd, you doing okay? You're working it out? Okay. Okay, so pick some x values here, Sean. Plug them in, get your maximum y value. You did, Carson, be right there. Agnes, you doing okay?
Yeah.
Okay, so
what's-
2.
You're saying y
Oh, and be careful, I gave you
is equal
should be x
to
minus 2 is what I
2
gave you
minus
guys.
2. So what's y equal to? 2 minus 2.
Now, plug your 2 in.
Yep.
What's 2 minus 2?
What's this number?
0. So put 0
Zero?
there. Here,
What's 0
and then
minus
do
2?
same thing for 4, same thing for 6. Okay.
And then what is the other one?
Yeah, yeah.
So now
that's
you have
good.
your x and y points, so you can draw.
For number 4, you're saying.
And drop
Well,
the
this
line.
one's the one we're doing. You missed
Okay.
one, I guess.
Oh,
Hello.
Hello. Can we get your picture at least? That way we have like
Okay.
a definite.
Please. Thank you.
That's right. That's right.
You never know. Some teachers say no. That's
Alright, where am I supposed to be?
Against lockers, I guess.
Lockers?
Against
Alright.
lockers, against the blank surface.
Yes,
Alright, we'll go out here for the lockers. Be right back, folks. We're going to go over this in just a second, okay? Very important.
Enjoy your picture.
Yes.
Represents the BPR.
Very good. He's gone. I follow orders. I'm a good rule follower, guys. Okay. Okay. All right, you ready? Number 1, or number 5, I should say. Okay, now I chose just to do 2 points. I did x0 and x1 and got this. Okay? You get something along those lines? Mark? Yeah, looking good. Okay, let's look at number 6. Number 6. Okay, something like this. Okay, again, I picked some x values, plugged them in, got the matching y value there. Okay, you got it, Alex?
I have different points, but it looks the same.
Different points will look the same. Hey, that's okay. Do you have to get the same points as I do?
I
No.
have 0, 2, and 4.
Mine's going the,
Okay.
why did I have I should have had a negative slope.
You might maybe you missed the negative 1/2 there. Now, are you guys ready to learn the shortcut?
I like this way.
You like this way better? Okay, and that's fine. So Reagan, good news. If you like this way better, that's why I teach this way first, because it's more useful in a lot of different situations. But if you want to learn the shortcut too, can't hurt, right? It can't hurt to learn the shortcut just in case you want to use it. So let's see if we can figure out what the shortcut is. All right, now you'll notice that most of these lines have a number that's not next to the x, right? So for example, here we have a -2. Here we have a -1. Here we have a 4. Here we have a 4. Here we have a +1. Okay? Can you see a property of your lines, or of our lines that we've graphed, where that 1, where does the 1 show up in this line? Where does the 4 show up in this line? Where does the 4 show up in this line? Where does the -2 show up in this line? Where does the -1 show up in this line? Do you guys see it? Matt, I'll give people a chance to look here, and then we'll maybe have you help out. Where do you see those numbers showing up in our graphs?
Can you repeat the question, please?
So again, you'll see here that in our equations, right, for example, I have -2. Here I have -1, right? The not the coefficient, the other number, right? So the -2, the -1, the +4, the 4, the +1, okay? They all show up in our graph here. And in fact, in the 3, there's not a number written here, but what number could we put in here? A plus what number?
1.
If I add 1 to something, doesn't that change the value? It'll be plus 0. Okay, so there's actually a 0 here too. Okay, so where do you see that? Well, for example, in this case, where do you see that 0 showing up? Okay. All right, Matt T, you want to help us out?
Yes.
Okay, what are these numbers?
No problem, which one?
Any of them. -2, -1, the 4, the 4, the 1. What are these numbers? You know what, where the line crosses the what? Not the x-axis.
No, it's the y-axis.
The y-axis. Look here, folks, right? What's the y-intercept here? It's at +1. Positive 1. What's the y-intercept here of this line?
What? Why?
Where does it cross the y-axis at what value?
I think 5. But I can't see it.
Well, count on your own paper, right? 1, 2, 3, 4. Oh, there's a 4 there. What's the number here? 0. And what's the y-intercept? It crosses through the origin. 0. What's the y-intercept according to this? 4. And 1, 2, 3, 4. There it is. Okay, let's look here. -2. -2. Let's look here. -1. -1. Okay. So that's great. That number that's not next to the x, that's your y-intercept. Okay, that's your y-intercept. If it's positive, you go up that much. If it's negative, you go down that much. Okay. What about this other number, the coefficient? Well, let's take a look at this line, this first line right here. What's the slope of this line? What's the rise? What's the run? To get from this point to this point, I have to rise how much? 1, 2, 3. And run how much? 3 over 1 is, oh my gosh, it's 3. Let's check it over here. Okay. Let's go from this point to this point. To get from here to here, I have to rise how much?
2.
Down 2, right? And then right 1. So -2 over 1. -2 over 1. Oh, that's -2. All right, let's go over here. Number 3. What's the slope of this line?
0.
What? The y-intercept is 0. What's the slope? Let's count it. To get from, let's say, from here to here, I have to go up 1 and right 2. And the slope is 1/2. Okay. What's the slope here? From point to point, I have to go
-2.
down 2.
Left. Right.
Right 3. -2 over 3. There it is. You see it? What's the number in front of the x here?
0.
Not a 0. That's a coefficient. It'd be a 1, right? Because 1 times x, 1x. Or the slope would be 1 over 1. And look at this. Do we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1 there? Okay, for the slope. And then here, -1/2, down 1, right 2, down 1, right 2, down 1, right 2. Okay? So the long story short here is that we can use the slope and the intercept. We can pull the slope and the intercept from these equations as they're written. Okay? This is called slope-intercept form. When you have y by itself, okay, this is slope-intercept form. Write this on your paper, okay, or commit it to memory. You may already have it memorized, and you're like, I don't even know what that means, but like y goes mx plus b, I know it's something important. This is what it is, okay? The slope is the m. The y-intercept is the b, okay? Slope-intercept form. Okay, super important. So let's quickly do 1 or 2 more graphs. Well, a couple more graphs actually I have for us. All right, so flip over to the back. Of course, Matt. Of course.
Why would you ask that?
I wouldn't. Oh, no. No, don't blame Matthew. I would never think of forgetting the homework.
What is wrong?
Shh. I would. Yes, yes. Go. Thank you for waiting. Yes.
I didn't get my flashlight.
Folks, don't worry. Shh, I was not going to forget. I was not going to forget. Okay. I don't know where I put that pen. Where did I put my black pen? All right. Well, I'm. Oh. All right. Anyway, let's try another one here just to see what I'm talking about. All right. So let's do maybe a practice one. Okay. Let's try again. We'll graph y equals -3 over 2x plus 3. Again, slope-intercept form. Y equals mx plus b. Okay? Now, again, if you like using the table, use the table. Okay? Here in this case, what kind of x values will we pick if we use the table? We want to pick x values that are divisible by what? 2. 2's in the denominator. 2's in the denominator. So you want to pick them. But we're not going to use the table. We're going to do it by using slope-intercept form. Okay? So, Dylan, What is the y-intercept of this line? Which number is the y-intercept?
3.
It is the 3. Very good. If you got help on that, thank you to whoever helped him. If not, you got your own. Good job. Okay, so 3. So on the y-axis, 1, 2, 3. Plot a point. Okay?
Write down the thing. Y equals -3/2.
Okay. What is the slope number here? What is the slope number? Okay. What is it?
Would be 2.
It's close, the whole thing.
The whole thing. It's
Negative 3/2. Yes, because remember your slope is a fraction normally, right? So from this point, you don't start at the origin. The origin's not on your line necessarily, right? We do know that this is a point. So from here, how should we count if our slope is negative 3/2? We should go down 3, so 1, 2, 3, and right 2. And we can keep doing it if you want to get more points. Down 3, right 2. Down 3, right 2. Instead of going down 3 and right 2, what other directions could we go? So up 3, and then I should go left 2. So you can go in the exact opposite direction if you want to as well. And then we'll connect the dots to create our line there. Question, Matt?
If you like do the graph like that, do you have to like tell you like the point? Like, do you have to write down the x value and the y value, and then you'll just have a graph?
If I'm asking you graph this linear equation, you can use whatever strategy you want. If I say graph a linear equation and use a table, I want you to use a table. If I say graph a linear equation and use using slope-intercept form, I want you to use slope-intercept form. But if it just says graph a linear equation, your choice. Reagan might want to use a table, and she's great to use a table. That's great. Do it. If you want to use slope-intercept form, use slope-intercept form. Your choice. All right. So we all feeling pretty good about that slope-intercept form stuff? So again, long story short, if the directions just say graph the line, you can use any strategy you want. Right now we know table and we know slope-intercept form. Okay? I have 2 other weird lines that I want to talk about real quick, and then we'll give you guys your homework. Okay? And that is an equation of a line like this. Y equals 1. And the equation of a line like this. X equals 3. Okay. Now, believe it or not, y equals 1 is in slope-intercept form. It is. But I'm not going to have us worry about that for right now. Let's go back to our old strategy of a table. Okay? When we go to use the table here, we pick x values, right? So let's go to Erica. Erica, pick some x values for me here for this line. Again, we're graphing this one. Just pick some x values for me. 6. Give me at least one more.
The 2.
2. Okay, I'm going to pick like 0 as well, just for fun. Okay, but that's fine. 6 and 2 would be enough. Okay, now, normally, Erica, once we pick those x values, right, we plug them back into our equation. But there's a problem here. Is there an x for us to plug back into? No. What do we know about y, though?
Equals 1.
It is 1. So that means if I have a 6 here for x, what do I got to put in for my y? 1. If I have a 2 here for my x, what do I got to put in? 1. If I have a 0, 1. You get the idea. So now I have points, don't I? We'll just plot these points. 1, 2, 3, 4, 5, 6, 1. 1, 2, 1, 0, 1. Okay, and we'll just connect the dots. Okay. What kind of line is this?
Constant.
It's constant. Very good. Constant. Okay. We could also say it is a horizontal line as well.
Yes.
Okay. So if you guys want to see this, I can write it more clearly in slope-intercept form. Like this. The slope here is a 0 slope. Because the rise is 0, right? We're not going up or down. So the rise is 0, the run is 1 or 2 or whatever you want to say there. Okay, the run doesn't really matter as long as it's not 0 as well. So rise or run would be 0 over 1. But this is the original equation. Question, Matt?
So is that, can we just plot 1 on like y1 on the graph and then just draw a straight line? We only have
If you want to, yes. But again, if you need to come up with more than one point to help yourself, make the table. Okay, the table will guide you most of the time. Okay, last one here, x equals 3. Well, if y equals 1 made a horizontal line that was constant, what do you think x equals 3 is going to do?
Make it horizontal.
Yeah, what's that one called? Vertical. So let's see. Let's make a chart. Okay. Now, with this equation, okay, before when I asked Erica here to pick some x values, she could pick any x value she wanted, and then we try to plug it in, but the y is just always 1. Here, if I asked Erica to pick some x values here, would she have choice about what x values to pick?
No.
What does her x values have to be?
3.
3. No matter what she says, we've got to pick x values of 3. And then, well, what about our y values, though?
Cancel by 1.
They can be whatever you want them to be because, again, the x and y, they're not dependent on each other. X just has to be 3. That's the only thing that has to be true. So I can say 1, 2, -5 here if I wanted to. Doesn't matter, okay? Because the x value just has to be 3. So we plot these points. 3, 1, 3, 2, and then 3, -1, 2, 3, 4, 5. Okay? And there's our line. Okay? Questions on any of that? No? Okay.
Can you write this down for these two? Look, we're taking lots of notes here that are important. You might have to get that.
Okay. So your homework is the evens on this paper. You may use any method you want. The directions don't specify. If you want to use tables on all of them, use tables. If you want to use slope-intercept form on all of them, use slope-intercept form. It's your choice.
Cash money.
Cash money. Okay. So the evens. Okay. You have 6 or 7 minutes here. You can probably blow through most of these if you just use a shortcut, or a couple if you use the table. So the evens, please. Just yes, 2 through 12. The evens. Okay. So let's get these done here, folks. 2 through 12, the evens. And if you have any problems or questions, I'll come around and help too.
Home and Laura take a nap.
I understand.